Hello everyone. Today I'd like to give you a tour of a new feature that we've recently introduced to our Golem Python API, which is the service model. The service model allows you to run long-running processes within the Golem network, and as such it's kind of different to what we've been showing you in our examples up until now. So let me first tell you about the goals for this session. I'm going to assume that you have little knowledge of the Golem APIs themselves. So I'm going to start with an overview with an introduction of those, just to make sure that we're all on the same page. Later on, I'll explain the new model, the service model itself, and more specifically, I'm going to compare it to the task model that we've had so far. And finally, I will do a live demo using one of our examples from the Python API to show you how it runs, and possibly show you some basic small modifications that you can make, and to see how they influence the result. But before all this, there's one question that you're probably going to ask yourself: why would you want to build a Golem service in the first place? So here are some points that I believe are showing you the strengths of creating such a solution. So the first one is the fact that the Golem network is decentralized, and without having a central authority in place, it's also censorship resistant. What this means for you as a person who creates a long-running service is that you can achieve good uptime and possibly scaling as well, without having to use some centralized cloud provider for your program. Next up, we have the fact that everything we build is open source, so it's really all about being inclusive and accessible to everyone. You can tinker with our code, you can audit what we create, so you know what you're running basically. And finally, we've put a lot of effort into those new high-level APIs that I've already mentioned, to make sure that it's simple to integrate with Golem, and that it's simple to run whatever you need to run within this network. Right, so with this out of the way, let me introduce you to those SDKs or those high-level APIs that we've created. I'm going to show you a diagram which might be a bit confusing at first, but let's just focus on what's the most important in this case. So your entry point to the Golem network is the Golem Daemon. And this daemon is called Yagna in the case of the new Golem network, and it handles the communication with other Golem nodes. It handles all of the market interactions, spawning of execution units, and all that stuff. So the payments as well. So the daemon itself is basically your node, your gateway to the Golem network. And by you, I mean the requester. So the side which would be creating some demand within this marketplace, so that you want something computed, right? But the daemon itself doesn't really handle any sort of higher level logic. So to control it, we have the elements we call agents, and these agents are usually the applications that you as a developer are going to create. And here is where those high-level APIs that I've mentioned a couple of times come into play. So we currently support two of them. One is the Python API or Yapapi, and the other one is the JS API. I believe there is a typo here, but this is JS API. And so you can use those as libraries in your project to achieve different, to achieve various interactions with the daemon. So, and those are high-level ones. So you're going to be able to, for example, spawn instances of your service, or create a task that you want to compute, and the daemon is going to handle all the rest. So most importantly, is going to make sure that whatever container and code you've created is going to be properly executed on the providers, so on the nodes within the network. Right. So let me now switch over to the browser, and I'm going to start with showing you the where you can find those APIs. And by the way, all the links that I'll be using during this presentation, you'll be able to find in the video description. Right. So here is the Python API, Yapapi. You can find it on our GitHub page under Golem Factory /Yapapi, and you can see in the releases page, if we scroll down to the release 0.6, should be here, that we've introduced high-level API for services. So starting with the version 0.6, you'll be able to use the interface that I'll be presenting today. And just for clarity, the service API is currently only available for Python, so it's not implemented in the JS API just yet. We are actively working on porting it to the JS API as well. Okay, so this is the API, but you're probably not really able to tell much about it. So the best place to start, the best place to learn about Golem development is going to be our handbook. So I'm going to switch to it now, and you can find it under handbook.golem.network. And this is our main page for all the documentation that we have, and you're going to find how you can start being a requester, but you're also going to find under developer tutorials some more in-depth tutorials on various aspects of the Golem network. And so before I actually dive into more details, I mentioned that I'll explain the difference between the two models that we have in the Python API. So let me do this. Let me do this now. So first off, we have the task model. So this is what we've been showing you so far. And the task model assumes that you, as a developer, have a specific computation that you want to achieve, which can benefit from being distributed over a number of nodes. So this is illustrated with this very simple diagram that you have some problem which you can divide into fragments, and each of those fragments can be independently computed by a node, by some execution environment. So in our case, the simplest abstraction that you can think of is you divide it up into a number of chunks, and you send each of those, one or more of those chunks, to some provider, and then gather the results and interpret them in some way. So you might want to merge those results, or you might want to get the specific result from one of those providers. So some examples of such problems can be seen here. So we have a couple of like, complete examples. The one which illustrates, I think illustrates best what we achieve here is the hash cracker, right? So given a single hash that you want to crack, you're going to try and match each word from some list, from some dictionary, and see whether it matches what you're trying to crack, basically. So this dictionary can be split into sections, can be have a number of fragments. Each of those fragments can be sent to a different provider, and the same logic will be applied to each of those fragments, right? So you're going to essentially go over the list and try each of the entries and see whether it matches the original hash, basically. So that's the task model in essence. How does it differ from the service model, though? In the service model, we are not really interested in parallel execution of a single task, but we're more interested in having some long-running code potentially spawned on multiple nodes to be available for like a long period of time. And as such, if we take a look at the introduction to the service model, the first thing that we show is the life cycle of such a service, which kind of implies that this is the fact that it's going to be long running is kind of the main idea behind it. Because in the task model, you would fire a task. It could take a long time to to finish, but it would only be about getting some single result. In the service model, however, you can spawn a number of instances and have them running, and for example, only interact with them at some given time. You can send commands to them and expect some output. So you can, for example, be collecting some data. This is this specific kind of use case is shown in our example number 1, which is the simple service, and this service is basically generating some samples over time, which you can then download and create a plot out of them. So you have a service that's running somewhere in the network, and you just periodically communicate with it using the high level API to get the result. Okay, so now let's take a more detailed look at one of those examples, and I believe the simplest one is going to be the example 0, the hello world for services. And I'll not follow because what happens here is you can you can see the whole kind of the code for this example. But I'm going to walk through this in kind of a different order. So I'm going to start with how you actually provision those services, right? So here is a section about service provisioning. It defines a Python function which uses the Golem object that the high level API, the Yapapi API, provides as kind of the entry point, the main class that you interact with. This Golem class has some parameters passed to it, which will be used globally. We're not really going to be focusing on them just yet. What we're interested in is how this object, once initialized, is used to run a service. So we have a single function called run service, which accepts as a parameter accepts the class representing our service, which we'll see in a moment. And also it allows us to specify how many instances we want to start initially. And once this function is finished, it gives us a cluster object that will represent our cluster of instances running our service code. So essentially, this is all you need to start your own service. Of course, the implementation itself is going to be a different story. But in terms of how you run it, that's basically all you need. Now, let's take a look at this cluster object for a second. So below we can see how we monitor the state of our services. So we have some loop which checks the time. Its only purpose is to make sure that the service doesn't run forever, right? That we at some point we want to stop running it. But the more interesting part is this for loop here. So it uses this cluster object that we've just seen, and taking its instances field, it allows us to loop over the instances that are currently running our service, and we can use that instance object to query, for example, the state that the instance is in, or the name of the provider that it's running on. Okay, now in terms of the service implementation itself, let me jump to it now. There's going to be, well, so I mentioned that the Golem object expects us to pass it a service class, and this means that in order to define our custom logic, we will need to extend this class and define a couple of methods. You can read more about those methods here in the docs, but the most important ones are going to be get payload, which essentially tells us what image our providers should use to execute our stuff, to execute our code. And then we have start, which will be run once for each instance when it's starting up. We then have the run method, again tied to a single instance whenever it enters a specific state. And then finally, if we need to perform some cleanup on shutdown, we have a chance to do so using the shutdown method. So looking at the implementation, let me jump to the entire code. So this is our entire service class, and it has 3 of those methods that I just described. So there is get payload right here. There is start, which in the case of this example simply runs some shell loop that will be writing the current date to a file. We don't really have to bother too much with the actual implementation. And then we have the run method, which contains a loop that will periodically read the output of what we started here in the start method, and then it's going to obtain this result and print it out. By the way, one important note: all of this code is running on the requester side of things. So it's running on the machine that's also creating our service instances, right? That's provisioning those. So what you can see here is that we're using something that's called a context, a work context, to execute some commands on the providers themselves. So whenever we use this self.ctx, we're actually scheduling some actions to be executed on the providers, on the provider, and not locally. And once we call commit, we can then obtain those results from the like remote nodes. But this is something that you will see in other Golem examples as well. So if you need some more details, you can take a look at the handbook, for example, at the Hello World task model example. It goes into some more details related to this logic. Right. So this is our date service implementation, which we then start as I've described previously. Now let's take this specific example and try running it locally. So if we take a look at the diagram that I've shown you before, what we're going to do is, first off, we're going to start and set up our Golem Daemon so that we have a Golem node running locally. And then we're going to run the Requestor agent, which is the example that I've just shown you, that takes advantage of Yapapi as its library to run some service. Okay, so this you may be familiar with this, but as I said, I would like this to be accessible to everyone. So I'm going to start off with running the Golem Daemon from scratch on my machine. So let me jump back to our handbook, and there's actually, under developer tutorials, you have this section called Requestor Development Quick Primer, and this takes you through the steps that you need to perform in order to have a running Yagna daemon. So first off, I'm running Linux, so I'm going to be performing the steps for macOS and for Linux. What you need to make sure is that you have the proper version of Python and that you have Git available on your system. I'm going to skip over those steps. Then we don't really need any crypto right now, since we'll be running on the test network. That doesn't require us to have actual GLMs or ETH. So Now let's see how we run the daemon. To install it on Linux and Mac OS, we have this helper script, which I'm going to copy now and move to my terminal right here and paste it in. So this should take care of installing the latest stable version of Golem on my system. Right, so the script is finished. We can verify. So yeah, I'm sorry, I'm skipping over the Windows installation because it requires manual installation as of right now. So you need to download the package and place it somewhere on your path. Now let's confirm the versions, the installed versions. So to do that, we can go ahead and type yagna -- version. This returns us 072. Yagna comes with a binary called GFTP, which Golem uses to perform file transfers between the nodes. So we can verify that we have the same build and commit as the Yagna version. Everything looks fine, so let's continue. Now we can run our Yagna node locally. So let's copy this command, Yagna service run, and let me just paste it in right here. Right, so we got a bunch of logs. Everything seems fine. As I was doing a clean installation, clean start, we don't really have any funds yet. Even though we're running on testnet, we still need to request those funds to be transferred to our wallet. But before we do that, before we get some test GLMs, we need to create an identity for our requester. So let me switch back to the docs. Here we have the command I've just highlighted. Apkey create and some name. So this allows us to create a new identity for our Yagna node, and we'll see in a moment why we need this. So switching over to the terminal, let me open a new window, and I can paste in this command. If I don't specify a name, it's going to tell me that I need to specify it. I need to provide a name for our key. So let's name it. Right, and this gives us back the app key. We can verify that it is indeed created with Yagna app key list. So we have a table with one entry. The key here matches what was given to us upon creation, so that's all good. Now, having this created, we can request some test GLMs. So on testnet, all you need to do is you need to run this command, so Yagna payment fund, and after a moment, and you can see in the logs up here that something's happening. We're requesting some funds from our faucet, and yeah, after a couple of seconds we've received those. We can verify that by running Yagna payment status, and this tells us that we're using this token and we have an amount of 100 of those tokens. All right, great. So last thing that we need to do is we need to enable our daemon as a requester. This needs to happen each time we restart, each time we run the Yagna daemon. So this allows us to perform payments on the network. It's kind of a precautionary step once you're on mainnet, but it's the same thing running on the test network. So let me run this command. We can see a log saying unlocking wallet, and it's successfully unlocked. So everything looks good. So yeah, we have a Yagna node running. So if we look at my diagram, we have this part good to go. So the Golem Daemon is now initialized and set up. And the next step is to create our Requestor agent, which in this case is going to be the example that you've seen a couple of minutes ago, and have it use Yapapi in order to communicate with the Golem Daemon. To do this, I'm going to jump back to our browser here and go back to the service model example here, and I'm actually going to copy this Requestor agent code. So here we go. And now let me jump to my local terminal. Now let's create a new directory for this project. Let's call it services example and go into this directory. And now I'm going to create a new file called let's say requestor_agent, and I'm going to paste in the code that we've just seen. So this is pretty much everything we need to get our service running. As you can see from the requirements from the import, the only package that we might not have at this point is Yapapi, so the Golem API itself. So what I'm going to do now is I'm going to quickly install it using pip, so Python's package manager. Okay, there we go. So now we should be able to run this example. Let's try doing so. So we have Requestor agent. We need to make this executable like so, and then we do like this. So this should run our file, and there we go. This is actually expected. So Yapapi is telling us that we have not specified the application key for our Yagna node. And if you remember, I'm going to switch back to Yagna now. If you remember, when we created our app key, we had this this key value right here. So this is actually what the high-level API expects and what it requires in order to communicate with the proper daemon, basically. So let's copy this key and jump back to our example. And now I'm going to set an environment variable, which is called Yagna_app key, all capitals, and paste in this value. So if I do it like this, and now say /requestor agent, this Python script is going to be run with this environment variable set. So let's try this now. Okay, now we're seeing something else. So it's currently hanging, doing something. And as we can see, we've just struck an agreement with one of our providers, and we have some logs which are telling us the state of our instances. So our instance number 0 is currently running on this provider, and we're getting those date outputs from it as well. So there's nothing fancy. It's just the output of the date command, but it's kind of telling us that there's actually our logic is actually running on a node within the network. If I remember correctly, this example is set to run for a minute, so we should see it closing in a couple of seconds. There we go. So once a minute has passed, we can probably tell from the output of this command. So this is the time that we started, and this is actually the last date that we've received. So it's more or less a minute later. We terminate the agreement, and we have all like the closing logic of the API. So it's telling us how much test GLM we've paid for this run, and like what provider computed for us. Cool, all good. So what if we wanted to run this, this dummy service, hello world service, on more than one provider? In the case of our example, this is specified in the code itself. So let me open it again. And if you remember, in the main function right here, we had a call to the method run service, and it specifies the number of instances that we want to run on. So if we change this to 2 from 1, we should probably see a somewhat different output this time around. So let's try this again and see what happens. Okay, we have 2 agreements with two different providers, and now our logs are showing us the state for 2 instances. So just like here, instance 0 is instance 1, and we're getting 2 outputs from the dates, which are actually 1 second of one another. So this depends on when exactly our service was first started. Cool. So that's more or less all there is to this specific example, and this is how you would. I can close this now. So let me Ctrl+C. This is how you would actually integrate with Golem yourself. So to recap, the most important part is the Golem class, which you import like this, and which can be used to actually instantiate or provision our services. This object is used as a context manager in Python, meaning it has this with keyword used, and once it's instantiated, we use it inside this block. And so this is like the main entry point. The parameters that I was telling you about, so budget and subnet tag, there is more of those possible, and they all refer to kind of the global setup. So the budget is how much your total budget that you're willing to spend on running some computations with this Golem instance, and then the subnet tag allows you to specify the specific Golem subnet that you want to run on. This is especially useful for testing purposes. So for testnet, for example, on mainnet you're going to have plenty of providers available on the default network, but then there you would also be spending actual GLMs. If you want to learn more about the specifics, like why why are those methods using async, so why are they asynchronous, and how this kind of interacts with Python's async IO. I would encourage you to take a look at our introduction to the task model, and specifically this example, since it goes over the details and the reasoning behind those methods. Cool. So thank you for watching. Once again, as I mentioned, all the relevant links you can find in the video description, and I hope you're going to have a good time building stuff with Golem. So thanks, and see you later.